So now that we've gone over the pigeonhole principle, we're going to look at the generalized pigeonhole principle. And I'm going to start by stating it formally, and then we'll look at a concrete example after that. So let's say we have N pigeons that fly into M pigeonholes, and K represents a positive integer such that K times M is less than N. So K times the number of pigeonholes is less than the number of pigeons. Then at least one pigeonhole contains K plus 1 or more pigeons. So again, we're going to look at this through an example. We're going to pick some numbers here. So let's say that N is 9. That represents how many pigeons I have. The number of holes, M, is going to be 4. And then for K, I'm going to go with K being 2. K needs to be a positive integer. So then if we look at K times M, that's 8. And 8 is less than 9, so that means K times M is less than 9, is less than N here, which is a condition that had appeared up here in our generalized pigeonhole principle. So now let's think about this kind of scenario using our function idea. I have 9 pigeons on the left. I'm just going to use a dot for each one. Pigeon 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then over here, we had 4 holes for them to go into. One, 2, 3. And so really the pigeonhole principle has to do with how spread out can I make these pigeons. So if you look at it, let's see, the first pigeon, let's say the first pigeon goes in the first hole. We're just looking at an example. This doesn't have to be the case, but we're trying to measure like how spread out can these pigeons go. The second one could go into the second one, the third in the third hole, and the fourth in the fourth hole. Well, now the fifth pigeon would have to go into one of the ones that's already got a pigeon in it, because each one already has one. So maybe the fifth one goes into one, the sixth one, again, we're trying to spread them out as much as possible here. And so this last pigeon, pigeon number 9, has to go into a hole that already has 2 people in it. So let's say it goes into this last one, right? And here is a hole that has K plus 1, which in our case, K is 2, so 3. It has 3 pigeons in this hole. So in the case where they're the most spread out possible, there has to be at least one hole that has K plus 1 pigeons in it. It could contain more than that, like if all the pigeons flew into one hole, could contain more than that, but it has to have at least K plus 1 pigeons in it.